Hi, welcome to Simulated Engineering. Today we will see how to create a fatigue block cycle in FEMFAT. So first step is to input the FE entities, groups, stress data and material data. Then you will go to load spectra, and in load spectra just click on new here, just press OK, and the number of steps, if there are three steps in fatigue cycle, then you can create three. If there are four types of fatigue cycles, four types of different four types of different cycles in your fatigue. Suppose one is going to P plus P to minus P, second cycle is going for plus P to 2P to minus 2P, then you can create in that fashion. So in current scenario, there are three types of steps here. So I will press 3 here. Then first step is going for plus P to minus P load for about 300 cycles. And I have solved the abacus ODB for plus P to minus P. And I will use the same ODB for second step also. Second step is nothing but plus 2p to minus 2p, and it is going for 200 cycles. And here I need to put 2 here, and I need to put 2 here also. Then the third step is plus 4p to minus 4p, and load, and it is going, and it will test will be conducted for 10 cycles. And so I will put 4 here. What is block cycle in detail? So suppose there is a fatigue test we have performed in this component, where first step is to load the component from plus P to minus P for 300 cycle, and then we will stop the test and we will load the same component in step 2. We will basically increase the load to plus 2P to minus 2P for 200 cycles. And after this test has been done, then we will load the same specimen to step 3, which is plus 4p to minus 4p load for 10 cycles. And if someone asks you before even testing, like simulate and let us know will this product sustain this fatigue load or not, and you need to create the block cycle in FEMFAT to know whether this is above one block cycle or not. If it is above one block cycle, that means that your component will not fail under this cumulative damage test. And if it is less than one block cycle, then you can say your component will fail under this cumulative damage test. FEMFAT uses this minor rule to calculate this block cycle fatigue. Then you may ask, what is minor rule? So let us go to the next slide. Like, minor rule says that basically it calculated damage, and it says that damage is cumulative in nature, and every fatigue cycle have its own damage. And when the total accumulative damage is equal to 1, then it says failure occurs. So damage should always be less than 1, so that we can say it has passed one block cycle. So and the equation of minor rule is quite simple. It says that damage is cumulative in nature, and it says if for a particular fatigue load, the n is the total number of cycles the material can survive, and small n is the number of cycles for that load that it is going during its lifetime. So it says that the summation of Ni divided by capital Ni is equal to damage. So this is how it calculates the total fatigue life, total damage, and the reciprocal of damage is nothing but your fatigue life. So we'll see here by one example. So suppose there are two cycles here. If you see that, so there are two cycles. One is like N1 cycle, which is going for two cycles, and this is N2 is going for two cycles here. And this small gray color cycle, its total life is four cycles. And this big cycle, this cyan color cycle, its total life is six cycles. sorry, this cyan color cycle is total life is 4 cycles, and this gray color cycle the total life is 6 cycles. If we go like the cycles up to failure, and in actual loading condition we have got two cycles this component has run for. So we will calculate damage. D1 is 2 by 6 and D2 is 2 by 4, and it is self-explanatory. So it is coming out to be 0.83. So total damage is less than 1. That means it will go above one block cycle. It will go like total block cycle will be 1 divided by 0.83. And if you see the second example, in this, the small gray color cycle is having, in actual condition, it will run for 2 cycles, and the cyan color will run for 3 cycles. So in that case, it will come out to be the damage will come out to be 1.08, which is the damage is more than 1. That means this component will not sustain this loading condition. And if you want to calculate the fatigue life cycles, it is nothing but 1 by total damage. That is how FEMFAT used to calculate it. But suppose your block cycle consist of these two types of load. Suppose those are completely different in nature, then this method cannot be used because it just depends on your scaling of your amplitude stresses and your mean stresses. So you can't directly use FEMPAT basic to create the block cycle. So how to do it in such cases? How to create block cycle in such cases? So then there is one simple way you can use like this. This can't be used in directly in FEMPAT Basic, but in FEMPAT Basic you can solve each load case independently in FEMPAT Basic, like step 1 and step 2, and apply minor rule uh, in your post processor, or you can directly use Transmax or Channel Max. So this we will see in our next video. Thank you. Have a great day.